Okay. Hello, everyone. Welcome to AI-based audio forensics. My name is Daniel Paniagua. I'm an AI engineer for Gradiant, and today I'm going to present the three different models for AI audio detection that we have developed to answer three questions about the audio recording. Okay, where does the audio come from? Has manipulations on it, and has been generated by AI. To answer those questions, we have the traceability model, the segment detection model, and the synthetic audio model. Okay, so the first model, the traceability model, has for objective to determine the source or the origin of an audio using his technical characteristics and the metadata. For that purpose, we have developed the following architecture. Okay, you can see two levels of detection. The first level has the objective to identify if an audio is from a social network or original using only the metadata of the file. Okay, the second level only occurs if the first level determines that the audio is original. Okay, we do this because the metadata from a file can be totally removed or can be modified. So this second level determines if the audio is original or has been a modification over. Therefore, it's not original. Okay, so the first level, the metadata level, is done in three steps. First of all, we need to obtain the metadata from the audio. For that, we use the library MediaInfo that provide us two groups of metadata. The general metadata, as you can see, name, format, duration, etc. And the audio metadata with 67 different metadata fields. Once we have all the data, we need to do a little pre-processing. We need to remove the data that doesn't add value to the classification. We need to unify all the data that saves the same information, and we need to remove the unusable data. Then, and after this pre-process, we filter characteristics, all these characteristics, based on the MDA-based importance. Basically, this is a method that calculates the importance of each feature by evaluating how much the accuracy of the model is improved using that feature to split the data. Okay, so we generate this list of the most important, as you can see in the figure, and then we select manually, okay, the features that maximize the importance, the blue column, and minimize the standard deviation, that is the black line. And we use that seven characteristics: the bitrate, header size, format, bitrate encoded library, and codec E. Then, using those characteristics in a random forest model, we can classify the audio between WhatsApp, Telegram, Instagram, Twitter, Facebook, or it can be classified as original. If the audio is classified as one of the platforms, the model ends here, okay? But if an audio is classified as original, the second level of the model is activated because, like I said before, it can happen that an audio from a social network is classified as original because the metadata was removed or it was manipulated. So for this second level, we use two detectors, okay, to identify the codec and the compression level used on the audio by the platform. Codecs are the software used by platforms to compress and decompress the files internally, okay? These detectors determines if the audio is really bona fide or because most of the platforms leaves a footprint in form of a codec or in form of a compression level. So if we can detect no one, then it's original, okay? So you can see in the table all the codecs and compression levels that we can detect with these detectors. Both of the detectors are based on AST architecture, a purely attention-based model for audio classification. So first, the audio is transformed into a 128 band long spectrum. sorry, target spectrum is divided into 16 per 16 patches, and then, sorry, it was okay. Sorry for the. I think I was the 16 per 16 patches. Okay. Every patch is flattened into 768 unidimensional vectors, generating the embeddings. Okay, this is in the embeddings from the audio. To these embeddings, the architecture adds a special CLS token, okay, and learnable positional embeddings. These positional embeddings allow the model to capture the temporal relationships of the audio, and the CLS token is going to be modified by the transformer, and it's going to be the output of our model. So, okay, sorry. So these sequence, the positional embeddings, the patch embeddings, and the special token, it's presets by the different layers of the transformer. And finally, we map that special CLS token to the classification labels, in this case, the different codecs and the compression levels, depending on the detector. And only if none was detected, okay, we can determine that the audio is really original. In other case, there is a possibility of being sent by other platform, and we cannot say that it's really original. And that's all for the traceability model. The next one is the segment detection model. This model detects partial manipulations in audio, okay, identifying the exact moment when the manipulation appears. The functionality of this model is divided into 4 parts, okay? Pre-processing of the audio, front end for feature extraction, a back end for feature processing, and a final post-processing. First, in the pre-process, the audio is divided into 30 seconds parts, sharing 2 seconds in common, okay? Those parts are resampled to 16 kilohertz and normalized. Once we have done this as a front end, we use WAC2VEC2, it's a common architecture, as a feature extractor, okay? This architecture directly processes the waveform and generate acoustic embeddings for every 20 milliseconds. The backend model is based on the partial spoof multi-resolution architecture. We use GMLP, which is a multi-layer perceptron, okay, trained on different temporal resolution. This is important because the different levels are generated using max pooling and convolutional operations on the previous levels. So you can see on the image, the level 2 is generated applying max pooling and convolution on the embeddings from the first level. The level 3 on the embeddings from the level 2, and so on. So you can train the model with segments with different sizes. This is done only on the training, okay? I say this because the current model operates only on the basic level, on the 20 milliseconds window, generating manipulation scores for each basic frame. Okay, those scores represent the probability of that segment, okay, the 20 millisecond segment, to be manipulated. And once those probabilities are calculated for each segment, like I said before, we do a post-process in which we first we merge these common parts that we mentioned earlier, the 2 seconds common parts, maintaining the highest probability of manipulation. That's the first pass. Then the scores are smoothed using median filter. And then finally, with previously calculated threshold, is determined if the segment is manipulated or not. And finally, we group the consecutive segments together, determining which part is bona fide or it's a manipulation. Now, The last model that we are going to talk about is the synthetic audio detection model. The model specializes in detecting audio fully. Okay, this is important, fully generated by AI sources. This is our architecture. As you can see, there are two main blocks: the upstream, okay, the left one, and in charge of the feature extraction, and the downstream, okay, that use those features to generate the scores, the final scores. So, first of all, in the upstream, we use again what to vector, like the segment model, but in this case with 300 millions of parameters trained on 128 languages. Okay, it combines, as you can see, a convolutional feature encoder and a transformer encoder, generating embeddings from different internal layers. Okay, for each frame, similar to the segments. Okay, like 20 milliseconds window size. It's the same principle. Uh, Now, in the downstream, the first step is to combine all those embeddings from the upstream. That's the big difference with the segment model in one vector of 1024 dimensions, okay? Using a trainable weight sum, and that allows the model to learn which layers of the upstream are the most relevant for the detector. Then we use a small neural network that contains a linear layer, a value layer, a dropout layer, and a second linear layer that provide us to reduce the dimensionality of the generated vectors from 124 to 1024 to 256 features. Then, to reduce all the sequence of the temporal embeddings in a single fixed length vector, we use ASP, attentive statistical pooling. Okay, ASP is based on the statistical pooling, which summarize, okay, the previous sequence using only the mean and the standard deviation. Okay. The upgrade is that ASP introduced a mechanism to weight the most relevant frames before the statistical pooling operation. Okay. And the last layer is the score layer generates a score from that fixed vector, and we generate the previous step. And first, the vector is projected to 128 dimensions, and then using cosine similarity against a learnable vector that represents the direction of the bona fide class, we generate the final score. So, depending on a threshold, is determined if it's bona fide or a spoof. And that's all for the models. We are going to see a little demo. We are going to see all the models working on our platform in Veracruz. If you want, you can try for free the audio models we have seen, and also the image models done by Gradiant as well. This is our platform. This is a test platform. Okay, if you want to see the commercial platform for free, you can see here in veracruz.com, and you can try for free and for free. But you're going to see here some models are not on commercial platform. So first of all, I'm going to record my own voice to test the bona fide audio. Hello to everyone. My name is Daniel Paniagua. I'm 28 years old, and I want to thank everyone for the assistance. Okay, I'm going to export this bona fide. So I don't want to save it. I'm going to do a new analysis. Bona fide. Okay. Replay model, like I said, it's not in the commercial platform, so don't focus on that. But you can see the AI detection model said that it's bona fide. It's 100% original because it's not from any social network. Manipulations, manipulation said that it's completely bona fide. So everything's good here. Now I'm going to open my personal WhatsApp. Don't say it to my boss because I think he's in the room. and are going to send me a WhatsApp message, okay, audio message. Uh, uh, uh. Hello, everyone. My name is Daniel Paniagua. I'm 28 years old, and I want to thank everyone for the assistance. Thank you. So now I'm going to download my audio. Okay. As you can see, let's put it more difficult to the detector. It's going to change this is modify also. And we want to change the extension because we want to change the metadata to make it harder to the detection. Okay. So the AI model should set that it's really bona fide or original, but okay, we can see that it's 100% sure that it's from a WhatsApp audio. So now we are going to use the most famous platform for AI audio, the 11 Labs. I'm going to generate uh, a small text. We are going to be Adam. My name is sorry, Adam. 20 old. I want it. Everyone. Let's see. Okay. Like John said, I think you cannot hear it, but you need to trust me. This AI audio, but it's very similar to the human voice, like human voice. Now we are going to do an analysis of this audio. It should say that it's original from the platform, from the traceability, but okay, you can see that AI model detects that it's AI generated. And the last part of the demo, I'm going to make Adam look bad because he's going to say, I don't like bunnies. Okay, don't like bunnies at all. And we are going to make a little podcast. I'm going to ask Adam if he like bunnies. And we are going to make Adam a monster because he doesn't like the bunnies. So I'm going to go again. Hi, Adam. Do you like bunnies at all? Do you think they're cute? And now I'm going to import I think, yes, the last one. This is a response from Adam. I'm going to put it here like it was a podcast, spot audio. Oh, yes. Okay. And then the platform should detect, okay, here, podcast. The platform should detect my part as original, as bona fide, but the Adam part should say that it's manipulated because it's AI generated. The AI model said it's okay because it's not fully AI generated and it's 100% original. But you can see on the manipulations that detects the Adam part like it was an inserted. So that's all that I want to show. If you have any question, that's the moment.